So my name is Rachit and I'm doing this for my DCS D assignment part 2. So I have to do QAM 256 modulation. So here is my audio file. Let me show you my audio file.
Hello everyone, my name is Rachit Srivastav. My roll number is 17BEC1018. Currently, I am doing BTech in VIT University, Chennai branch. My field of interest is ML. I am doing this recording for my DCS digital assignment. Hope you are having a good day.
So that was my audio file. Now I'll show you the MATLAB code for that. So using the audio in info function, I've been able to import the audio file into the MATLAB. Using audio read function, I've been able to get the sampling frequency. Then I've set the time for this. Then using subplot, I can show you the plot thing. So this is my original audio, this is my time function, and this is the quantized signal. Since the frequency is very high because we have spoken so many things in a limited time interval, so you can see the frequency is very high in this blue region. Then comes the quantization part. So we are doing a 32-bit quantization level. So this is the graph for my quantization part. This is the original audio, this is the quantized part of my audio. So the technique is we are finding the absolute of the maximum input, then we are normalizing it so that during pre-processing the less time is taken and the process is faster. Then we are using this formula again to increase the efficiency of my processing. Using the subplot function, I am plotting my quantized signal, that is this thing. Then comes the part to draw the quantized waveform. A QN variable stores my input data, and using the find function, this formula, we have been able to plot the quantized signal as I've shown you. Now to show it in a better way, I am using some zoom in function, and so as you can see, it is you can see that the frequency is very high here right now. So to see it in a visible manner, I am zooming it a bit, and this is the zoom to quantized signal. Now comes the part for the okay, first we have to convert our data into decimal to binary so that it can be used in the QM modulation. So in 6 means the number of columns that we want when we are converting decimal to binary, and left MSB sees like the maximum non-negative number in the data input. So then we are using some indexing technique so that when we do reshape, there's no error because size should always be in real integer numbers. That's why I'm using this indexing technique so that when I run this reshape program, there's no error. And since my task was to do 256-bit QAM, so this is m is equal to 256 and then k is equal to log of 256. As you can see here, my k value is 8, that is log to the base 2 of 256. After doing reshaping, I am doing binary to decimal conversion, that because QM modulation takes input as a decimal vector, not a binary vector. Then I am doing this indexing part. So this is the random symbol that we are taking, and this is the scatter plot for our data input signal. So this is the part where I'm doing random symboling, and then this is the function for QM mod, that is QM modulation. So M defines like 256-bit we are doing. Data symbols is the input variable, and bin is the technique that we also use in histogram to draw rectangular columns that have a fixed width. So using this function, we are also adding addition white Gaussian noise so that our program is for a general purpose. We are adding some noise to our data, and as you can see, this is my final 256-bit binary symbol mapping. That is 256-bit QAM. So this is the 256 QAM binary symbol mapping, and then this is a scatter plot for that. Then I'm using this text command to show you in a text format what is happening, and this is the binary symbol mapping. So in this whole thing, my main aim was to do 256-bit QAM, and this is the code, and these are all the possible outputs that we have got. Original audio, quantized audio, zoomed in quantized audio, then the random samples, the scatter plot of my input data, and finally the 256-bit QAM. Thank you.